So scientific notation is kind of a spin-off on this indices topic, and something that you got to get used to seeing it written, um, because it's often used to display really large numbers and really small numbers, so scientific notation. Now, reason being that obviously in a scientific paper where there's a lot of text, you don't want numbers to get too large, and you don't want really small ones with lots of decimal places that end up going over another line or something like that. It also becomes a hassle to count all the zeros up. And so with this scientific notation, we can compare numbers just to see how big they are compared to other ones really easily, or how small they are without too much effort. So I'll give us an example of what a number looks like in scientific notation first, and then we'll talk about the different parts. So let's say I've got 23, let's do something simple, 23 million. So let's say you're talking about a number 23 million, and we want to write it in scientific notation. What we do is we take the first part of the number so that we end up with a number between 1 and 10. You can see 2.3, it's higher than 1, but it's less than 10. And then I've had to move the decimal place. So what I do is I times it by 10 to the power of something. Now I've had to move the decimal point rather. It was here. 1, 2, 3, 4, 5, 6, 7. So I've got to times it by 10 with 7 zeros. But conveniently, any 10 to the power of a number has that many zeros on the end. And you can try that out yourself. Let's say 10 times 10. Let's just do 10 to the power of 7, probably going to be quicker. 1, 2, 3, 4, 5, 6, 7. So you can see that works, 10 to the 7. So what you'll see is in a scientific paper, or maybe even a news article, something like that, you'll see it written like this. Now that lets us easily compare, let's say this is a distance between two stars or something, and you saw another distance was 4.8 times 10 to the 6. Straight away, just by looking at that 6 and that 7, you know it's about 10 times further away, which is really handy because often we don't care, to the nearest millimeter. We just want a rough idea of how big these distances are, and we can do that by looking at the second part of the number. So the first part, we got a number between 1 and 10. So you need to add a decimal point so that the number is between 1 and 10. The second part is 10 to the power of something. And for really large numbers, that's going to be a positive x. For really small numbers, we actually want to be dividing this number. And as we saw last lesson, if we were to put a negative here, well, that 10 to the 7 would flip down to the bottom and actually become a division instead. So x is positive for big numbers. X is, I should write like positive. X is negative for small numbers. What else you might like to write down? Okay, so what we need to do is be able to write numbers in scientific notation and also write numbers that are in scientific notation in normal notation. Now, unfortunately, the name for scientific notation used to be called standard notation. And so that means it's really difficult to know what you're talking about, if you're talking about normal numbers or scientific notation. So often you'll see decimal notation, which is this normal one, 23 million, or scientific notation. But that's something to be careful of. If you see standard notation, I know my brain often goes to just normal numbers, but it means scientific notation, it's an older term for it. So, write the following. Okay, spell following. Following in scientific notation. Okay, let's say I've got 4, 6, 7, 0, 0. All right, I need to write this number in scientific notation. First step, I need a number between 1 and 10 from this number. You can see the decimal point is going to go here, 4.67. Now, I've obviously had to move the decimal point from here. So remember, it's always at the end, 0.0000. I've had to move it 1, 2, 3, 4 times. So times 10 to the 4. And then, because this is a large number, that 4 is positive. I want it to be multiplied to get bigger than 4.67. I don't want it getting smaller than that. So that's my answer. Now, just as a quick aside while we're here, you can actually write 4.67 times 10 to the power of 4, and that was what we started with. This button here does times 10 to the power of, or you can actually just write it manually, 4.67 times 10 to the power of. That also works and actually looks like scientific notation. This one says times 10 to the power of x, but when you type it in, it doesn't look like to the power of x, which I think can get a bit confusing. All right, B. Let's go back to black. Which never works as smoothly as I want it to. B. Let's say 0.00000083. Now I need to put the decimal point somewhere that makes that a number between 1 and 10. If I put it here, I'm actually going to get 0.83, which isn't between 1 and 10. That is less than 1. So I can't use that number. Let's go back a bit. It needs to go here. 8.3. Is that number less than 10? Yes. Is it greater than 1? Yes, it is. So 8.3. Now, how many times did I have to move the decimal point? 1, 2, 3, 4, 5, 6. I had to move it 7 times. Times 10 to the 7. Now, this number is really small. 0.000. That's obviously quite small. I need to be dividing by 10 to the 7, which means I need my negative there, because that makes times 10 to the negative 7 the same as divided by 10 to the 7. So that's really big numbers, really small numbers. And let's just see on the calculator. Your calculator will most likely just write this one as scientific notation itself because it can't fit it in. You would have seen this come up before when you've gotten some questions quite wrong. And it just tells you, oh, there you go. Just fits that one. We're going a couple of digits more. So let's check how many, let's go to the 9. Oh, still fits, getting closer, 10. There we go. So it couldn't fit in all those digits, so it's given it to us in scientific notation anyway. Which is funny because we typed in a thing and it told us it's the same as that. No change needed. All right, let's go the other way. Write in decimal notation. Okay. Let's say 6.45 times 10. Let's be really annoying and write to the power of 11. Is this a really big number, you got to think to yourself, or is it a really small number? Now we're timesing by 10 to the 11, which is quite large, so we're going to get a big one. I have to move the decimal point 1 times, 2 times to get to here, but I still need to go another 9 times because I need to move it 11 in total. So I've moved it 2 times to get to here, and now I need to go 9 more places to get the decimal point to there. So 9 zeros on the end. So 2 of this number is taken up to get to the end, and then I've got 9 left for zeros on the end. Let's have a go at another one of those. 8.1 times 10 to the 6. Now, just think to yourself, how many zeros is this going to have on the end? Somehow got rid of a 6 then. Was it 6? No idea what I wrote before, but we're going 6 now. Because it decided to delete itself. So, 8.1 times 10 to the 6. Well, one of these is going to be used up getting the decimal point to the end. And we've got 5 left for zeros. So 8,150. So 8,100,000. Again though, for ones that fit, you can use your calculator. 8.1 times 10 to the 6. There we go. That only works for some of them though, because some of them are too large. You'll just be writing heaps of zeros and your calculator won't be bothered. Alright, one more question. Oh, let's get 2 more questions. Let's see. Let's say 8. I'm using 8 too often. Let's mix it up. 7.4 times 10 to the negative 9. Now this is going to be quite a small number. And also requires a tad more thought, I reckon, than going large ones. Just on where the decimal point ends up. Just a tiny bit trickier. Obviously we need to move 1 to get to there. And then I need to move again, so I'll add a 0 in front, etc. I need to work out how many zeros I add, but this one doesn't really count at the start because I haven't had to move the decimal point past it, have I? So we just need to keep that in mind when we're doing it, so we don't do too few or too many. So I've moved the decimal point once to get past the 7. I need to move it 8 more times. So that 0 doesn't count, and I've got 8 zeros here. 7, 4. Now let's test. Let's just count it out just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. We had to move it 9 times, and that's what the scientific notation indicated. And don't be scared to count it out in the test. Always better to be sure. There is nothing wrong with counting it out to check your answer. Alright, now they always chuck a few of these ones in there. Let's just see if they have. Oh, no, they haven't. We'll do one anyway, but they like to ask something like this. Solve, and then they'll just give a question, say 2.54 is 10 to the 8 times 6 times 10 to the 4 over square root of 3.4 is 10 to the negative, let's go 2. And then all it is a calculator test, just to make sure you can use your calculator. So 2.54 is 10 to the 8. And I want to times that by 6 times 10 to the 4. I'm not using my calculator correctly. And then we're dividing that by the square root of 3.4 times 10 to the negative 2. There we go. I might shorten that a bit as our answer, otherwise I'm going to be there for ages writing, but 8 point, let's say 27. 2 decimal places is nice. It's 10 to the 13. Quite a large number. Alright, have a go at the exercises. Thanks.